know some of you are still finishing, okay? The first part is just simplifying what we've been working with, and then the second part is solving because that's what we're getting into today. Okay, just for those of you that plan, we have a tentative quiz date from 5/1 to 5/4. Okay, we have 5/3 that we're going to go through today. And then 5/4 is very, very small. Okay, very short. We're thinking either Wednesday the 30th, so next Wednesday, but most likely that Friday, April Fool's Day. Okay, so April 1st. So around that, and then we get into graphing and then word problems to end the unit. So we will probably have another assessment short before break, okay, to get all of it in if we can. If not, there's no worries. And those of you that, I believe everyone will be here on Thursday. If you're not for the SATs, the videos will be posted, okay, to definitely watch those. And I've gotten plenty of, when you come in and you're like, well, I wasn't here, what did I miss, da, da, da. Always check Google Classroom. Last class we did activities in class to make sure everyone was on the right page in terms of simplifying exponents, evaluating rational exponents, and radicals. So if you're not sure, please check there. If you're still not sure, then send me an email, okay? But everything is most likely posted. Sometimes it could have not posted or forgotten, whatever it is. So just clarify, okay? All right, so for number 1, 54 over 64 to the 1/3. Any ideas? Yes, Kip. Okay, let's check this out. So we have the cube root, 54 over 64. Okay, now it's the cube root, and we're going to go through all of them. So we're going to check Kip's answer here. So we have the cube root of 54 over 64. What is the cube root of 64? Hayden? 4. Okay. Now, 54. What are two factors of 54? 9 and 6. 3 and 3. 3 and 2. How many of a kind are we looking for? Hayden? 3 of a kind. So we have 3 cube root 2. Okay? As our final answer. Okay? 3 times the cube root of 2 over 4. All right? Yeah. Mm-hmm. Correct. Yes. So with that, and you bring up a good point, in that case, when we break up 64, you have 8 and 8, and I automatically know 8 is 3 twos. So if you were doing this, for every pair, 1 comes out. I mean, every group of 3, another comes out, and then you multiply here. But it could have been 2 other factors where, say if you have 3 3s, you would take out a 3 and then multiply. But they all have to be the same. Okay? All right, number 2. Hayden. Careful. Over 3 is correct. Yeah, go ahead. Cube root of x squared over 3. Because we cannot take the cube root of x squared. Okay? So when you have rational exponents, for now, since we didn't rewrite into smaller bases, use your roots. Use your roots, okay, first to evaluate. So most of you might have done multiplying x to the 2/3 and 3/27, sorry, to the 1/3. We'll rewrite it as a root, okay? So you could see that you're taking the cube root of 27, all right? Number 3. Hey, okay, Eleanor? Yes. Okay. So we're first going to take the cube root of this guy. Cube root of 64 is 4. Cube root of x cubed is x. We cannot do anything with the cube root of y. So that stays as is. Then we have 4. Our negative exponent, where is that going? To the top, right? And then that y stays where it is. So we have 4x to the 4th cube root of y over 4y. Well, these 4's can cancel. And we have x to the 4th cube root of y over y. You cannot cancel those y's out because one has a radical and one does not. Okay? So that is your final answer. I'll move it up for those that can't. All right, number 4. Kaylin. Perfect. So we can't do anything with the 4th root of 3, so that stays inside. 4 goes into 7 once. There are 3 left over. 4 goes into 9 twice. There's 1 left over. 4 does not go into 3, so that stays where it is. Okay? Okay. By raising hands, for number 1, how many of you got number 1 correct? Okay. Number 2 correct. Number 3. Okay. Number 4. Okay. So why is there only 2 people answering that? If 25 of you are getting it correct, 24 of you are getting it correct. Come on. How about number 5? Grant. Good. The cube root of 125 to the negative 4th. Cube root of 125 is 5. Can't have a negative exponent, so it's 5 to the 4th. Okay, 1 over 625. Okay, so these right here should be done without a calculator. Okay, so since it was done without a calculator, if you're not sure what 5 to the 4th is and can't really multiply, then leave as is. Yes. Mm-hmm. Well, it's y to the 1/3. When you end up with 2/3, you can't have a radical in the denominator. So the cube root of y squared you have to get rid of, so you're back to where you started. So you had, if you have y to the 1/3 over y, when you subtract, you have 1 over y to the 2/3. You cannot have a radical in the denominator. So in order to get rid of this, which we haven't even talked about, we have y to the 1/3, top and bottom, which is exactly where we left off. So y to the 1/3 over just y, which is the cube root of y over y. Okay? Right? And that's, I'm glad you asked that because we haven't even talked about it yet, right? So that's one thing to keep in mind. You cannot have rational exponents and or radicals in the denominator, so you have to get rid of it, which is different than we would just multiply by, like for square roots, by y to get rid of it, right? Or the square root of y. Here it's a little bit different because we have rational exponents. Okay, great question. Okay, then we get into solving. Number 6. Campbell, what do we got? Excellent. X equals plus or minus 3. Divide by 2. X squared equals 9. When you're solving and taking the square root of either side, you have plus or minus. Okay. Number 7, Zoe. Okay. So when you're here and you take the square root, you have plus or minus. Can square root of 12 be simplified? Yep. 2 root 3. Because you have the square root of 4 times square root of 3. Okay? All right, number 8. Our factoring is, what do we got? Okay. Pearson. Okay, Christian. Perfect. Okay, when you have a trinomial, you multiply 3 times 3 to get 9. What multiplies to 9 and adds to 10? Okay, we split the middle here. Okay, greatest common factor of the first two is 3x. You have x plus 3. That's 1. X plus 3. Our parentheses match, so you group together. Side, and some of you left it as this, but it's set equal to 0, so you have to solve. X equals negative 1/3 and negative 3. Okay. All right. Number 9. Go ahead, Pearson. Excellent. Okay, so we just have quadratic form here, meaning our exponents are doubled. So we have x squared minus 9, x squared minus 5. And from here, you could set each of those equal to 0. But remember, you must include the plus or minus. But for difference of two squares, to remember, equals 3, negative 3, and plus or minus root 5. Which makes sense because we have how many solutions here? 4. What's our degree? 4. Okay, good, excellent. For solving, how many of you got all 4 of those correct? Okay, good. All right. Now, I saw some questions or highlights on your practice, especially number 15. And you guys that have this, make sure that didn't write it wrong, because I have a lot of mine crossed out. Just gonna make sure. To R, for S. Okay, so there's a number of ways you could do this. You could write it all under one fraction if you wanted to. You could cross cancel, which I did. That's why it could be a little confusing. If you wanted to just keep your numbers separate instead of multiplying, you could write as is. Okay, you could multiply if you want and then reduce or cross cancel. Then for your r's, you have r to the 8th, r. So what do we have? R to what power? Okay. Then our s's, we have s to the 7th and s. What do we have? Okay. Then the denominator, we have r to the 7th and r. Okay. Oops. And then r, s squared and s. Okay. So from here, the variables are pretty easy to do, right? Variables are pretty easy to do. Meaning, r to the 10th divided by r to the 8th, what do we got? R2. R to the 8th divided by, s to the 8th and s cubed. 5th, okay? All right, so these guys are taken care of. Now our numbers, anywhere we could cross out right now. Go ahead, Kate. 4 and 4. Okay, hold on. It's okay. And then we could have -3. Okay, so what we have left is 2. Then -1 times -3 is? Charlie, can you open the door, please? Okay, and that's your final answer. Yep. 20, you're right. It would be the 21st. Why the 21st? Thank you for that. Good. Glad you asked it. Okay, I just make a note. 1 over, why to the 21st? Good. Any other questions, especially on that first or anywhere? Go ahead. 41? The one that I crossed out and says 41, right? Okay. Okay. This one or the other one? 4. It's okay. All right. 81. 8 over cube root of 3. Okay. So you could do this a bunch of different ways, okay? But since they both have the cube root, right? 81 divided by 3 is what? 27. So cube root of 27 is cube root of 8. So because these are the same root, okay, it's the cube root. But now we're multiplying. So here, if I wrote it as it's all over the cube root. Okay, so you could even multiply 81 or do this separately. 81 times 8 and then divide by 3 since it's all under the cube root. Yeah, Kate. So when you're multiplying here, you could simplify. So with it, if I did 81 times 8 and then divide by 3 or reduce that fraction, okay, that's another way. So with it, you could look at, and I just found an error. So with this, let's do it this way. How can I simplify the cube root of 81? And we're going to check it. We're going to go through it because I just found a mistake. So 3 times the cube root of 3. Okay. Then we have cube root of 8, 2. Okay. So right now we have 6 times the cube root of 3, right? We still have our denominator. What happens? But just in same thing, right? We're just left with 6. Yep. So which is what we got. Okay. So you could do this a variety of different ways, okay? With it, this is combining your just your radical properties in general. Um, simplifying them both separately, and then simplifying you can. Um, dividing, you could do this a whole different bunch of different ways. Yeah. 45. Okay. So here you are subtracting this one, right? Right, James? This one? Okay. So you are subtracting, right? So right now, these guys are all you need. They're in common, right? So that's going to be in my answer. However, before we subtract fractions, what do we need? Common denominator. So which would be what? 6. So I'm multiplying this one by what? 3. So I have 6, 3. And this one, what am I multiplying by? Now am I able to subtract? Yep. That's it. Okay? Yep. Which one? The 2 to the 1/5? Just making sure. All right. Okay. So, what does 1/5 mean? The 5th root. So if I rewrote it, the 5th root of 2 times the 5th root of 16, okay? They're both the 5th root. So since they're the same, I can multiply these guys. 2 times 16 is 32, and then you're left with 2, okay? You would not, because it would be 32 to the 1/5, because this is not the same base to add those exponents, okay? So, Campbell, this goes back to what you were asking, why can't you multiply? Here's the situation where you can, because the exponents are exactly the same, and it represents the 5th root, okay? All right. So, unlike if you had, I think one example was this, you cannot multiply 4 times 4 because that's a cube root and that's a 5th root. Okay, so this is different than that. Okay, yep. hmm Where their radicals would be the same. Yep. And they're raised to a different exponent. So you would have to do, so if you did 15, right? You would have 5 over 15 times 3 over 15, right? So that means I would have to multiply, this is the 15th root, 4 to the 5th, and 4 cubed. You still cannot do 4 times 4 because they have an exponent attached. Okay? So you will see as you're going through it, most of the time when you see rational exponents, you want to rewrite those. Okay? All right? Let's take out our notes. You will need your calculators at some point, so please make sure you have those out. Yeah. Page 11. All right. So we are getting into solving, which we are familiar with in terms of square roots, okay? Now we're getting into with rational exponents as well as different roots. So, if we look at the first four that we have on the board, for number one, how do I solve this? Okay. Good. We take the square root and it ends up being plus or minus 5. What happens in number two? Go ahead. You're good. Good. Plus or minus 5i, which is not a real solution, right? So when we're taking the square root of a negative number, it would not be a real solution, okay, because we have imaginary. Now, for 3 and 4, how do I get rid of that exponent? What would I do? Go ahead, Kate. Take the cube root of either side. Now, x equals, what is the cube root of 125? 5, right? And it's just 5. It is not plus or minus because it's just 5 cubed, okay? How about if I took the cube root of negative 125? Yeah, Cap? Negative 5. So, when you have an even root, okay, when you have an even root, that's when you use plus or minus, okay? When you are solving an even root, you will then include plus or minus. An odd root, if you're taking your odd root of a positive number, you will get a positive answer. If you're taking an odd root of a negative number, you will get a negative answer, okay? So even root's the only time when you're going to have plus or minus. So if we look at number 5 here, what do you have to do first? Kaylin. Subtract the 6. So we have x plus 10 to the 6 equals what? 64. Now what do you have to do? How do I get rid of that exponent? Not distribute, because you would have 6x plus 10s. Yep. Take the 6th root of either side. Now, is the 6th root an even root? Yes. So we have x plus 10 equals, and x plus 10 equals. So, since it's an even root, the 6th root of 64, someone said it, was 2. But I also have negative 2 because it's the plus or minus. Okay? Even root, you will have 2 possible answers. And now we solve for x. So our first answer, x plus 10 equals 2. What do we got? Negative 8. Thank you. X plus 10 equals negative 2. Jaden? Positive or negative? Okay. All right. Now number 6. What do you have to do first? Add the 1. Good. Then what do we do? Yeah, Anna. Take the 4th root. Is the 4th root an even number? Yeah. So we have 2x plus 3 equals, and 2x plus 3 equals. What is the 4th root of 16? 2. We have 2 and negative 2. What are our two solutions? Yeah, Kip. Good. Okay, try number 7. Yeah. Question. This one? -8 and up. So these are, since you're taking the 6th root of either side, that's where it changes a bit. You might have imaginary ones in here as well. These are the two real ones that you will see on the graph. So 4 would be imaginary. Great question. Okay. Or it might do something on the graph totally different. Okay. Try number 7. All right. What is the 4th root of 256? Tatum? 4. So you have x minus 5 equals 4, and x minus 5 equals -4. So we have 9, x equals 9, and x equals 1. How many of you did get both of those? Great. All right, good. So this next part, you will need your calculator. 4. Okay. We're always going to round to the hundredths. Okay. So read it through. Okay. They're giving you the formula W equals 0.0167 L cubed, where L is the length. You want to estimate the length of a coral cod that weighs 200 grams. So how would I set this up? Okay. Good. So how would I go about solving? What would you have to do first? Eleanor? Before that. Kate? Yep. Okay. So 200 divided by 0.0167, round to the hundredths place. What do we got? Yeah, Kate. Mm-hmm. Good. Okay. Net equals L cubed. Good. Now, how do we get rid of that? Eleanor? Yeah. Cube root of both sides. What's another way you could do this as well? Instead of the cube root, say you couldn't find it in your calculator. What's another way? You could raise it to the 1/3 as well. So either way, you could take the cube root or raise this whole thing to the 1/3. Same answer. What is our length round to the hundredths? Go ahead, Eleanor. 22.88 centimeters. Okay. Was everybody able to find the cube root? Okay. Or raise it to the 1/3. Remember, in your calculator, you could go to math, and number 4 is the actual cube root, or anything higher is using number 5. Okay? All right. So now, we have rational exponents. Okay? We have our rational exponents here. And we want to solve. Okay? How do you think I can find what x is when I take x to the 1/2? How do I get rid of that exponent? Excellent. You would square. So you would do the opposite, okay, to both sides. Now, since I'm squaring, I do not have to include plus or minus. Okay, so what is 8 squared? 64. Okay, in number 2, what would I have to do? Cube both sides. Okay, what does x equal? 27, good. In number 3, what would you have to do to both sides? Good, we raise it to the 5th power. And I know it's going to be negative, because raising it to an odd power will make it negative still. What's negative 2 to the 5th? Yeah, negative 32. Good. And then last but not least, number 4 to the 4th power. Excellent. What is 2 to the 4th? Kate? 16. Good. Excellent. Okay, so that's our rational exponents just with, remember, because x to the 1/2 is the same as square root. So we're squaring both sides. Now we have, number 6 we'll get to shortly. What do you have to do to both sides? First. We raise it to the 5th root, or 5th power, sorry, of either side. So we have x plus 4 equals what? 32. Then subtract 4, and we end up with 28. Okay. Number 6 is different because now we have a numerator of 3 instead of 1, right? So what am I raising both sides to? Eleanor? Careful, careful, careful. We have 2x minus 7 to the 3/5. What do we raise to both sides? Kip? 5/3. It's just the reciprocal. So now we have 2x minus 7. Now 8 to the 5/3 means what in terms of radical notation? 8. Good. Okay, so 5/3 means the cube root of 8 to the 5th. What is the cube root of 8? 2. Then we take 2 to the 5th, which is 32. Then we solve. Okay? So, when you have that rational exponent, for now, if you have something other than 1, okay, as your numerator, you want to rewrite it in radical notation. Okay? So the cube root of 8 is 2. 2 to the 5th is 32. What is our final answer? And it could be left in fraction form. Charlie, what do you have? Why? It's not the square root. Okay? It's an odd root, but he brings up a good point. We took an odd root of both sides, so we do not have to include plus or minus. But if this denominator was even, then you must include the plus or minus. So 39/2. Okay? So if your denominator, when you say raise it to the reciprocal and that denominator is even, you must include plus or minus. So if we look at number 2 together, okay, and then you're going to do the rest on your own. for number 2 together, what do we do first? Good. So we have 3x plus 2 to the 2/3 equals 16. Now what? Yep. Good. So we have to raise it to 3 over 2. Okay. So that means I have 3x plus 2 equals 3x plus 2 equals. So 3 over 2 represents what? Yeah. Good. So what is the square root of 16? 4. 4 cubed. So we have positive 64, negative 64. Because we take the square root first. So the square root of 16 is 4 and negative 4. Then you have to cube both of those. Okay? So what I want you to do right now is complete the rest of number 2 and 1 and 3. If you finish with 1 and 3, then try 1 and 2 below. Okay? All right. So for number 1, good. You subtract 1 first, then you take the square root, and you have x plus 4 equals 5, and x plus 4 equals negative 5. So your two solutions are 1 and negative 9. Good. For number 2, we started this out, so you have 3x plus 2 equals 64, and 3x plus 2 equals negative 64. So we have 62 over 3 and negative 66 over 3. Can we reduce anything? Correct. Yep, good. All right. Now number 3 is also correct. We have 83 over 5. You raise both sides to the 6/5, so that's the 5th root of 32, which is 2. 2 to the 6 is 64. Then you solve. Okay. Any questions on 1, 2, and 3? Good? Okay. How many of you did get to 1 and 2? All right. So for number 1, what do we have to do to both sides? Jaden. Square both sides very simply. We have x plus 1 equals 36. What is our final answer? 35. Excellent. Okay. And number 2, what do you do first? Okay. Add 6. And what do we get? Negative 4. Then what do we do? Good. Good. Excellent. Now add 2. What do we do? Good. It's okay. Yep. Okay. Number 2, which is exactly what you said. Okay. So with rational exponents, you're raising it to the reciprocal. If your denominator is even, you have to include that plus or minus. Okay. Now the last thing that we will look at today is you always want to check your solutions, and obviously only if it tells you to. Okay. What we're looking for is everything that we found so far are possible solutions. Okay, and we say possible because one may work, one may not, both might not work. Okay, we always want to check them. So these are called your extraneous solutions. Okay, they are your extraneous solutions. So when it says to check for extraneous solutions, this is what it means. Say if you get an example of x equals 4 as a solution, okay, and I check, plug in 4 for x, okay, and we want to see if it equals negative 2. However, we're only evaluating, so we're not solving. What is the square root of 4? Just 2. Does 2 equal negative 2? No. Therefore, this solution would be extraneous. Okay? We're only taking the positive square root. Okay? Because we're just evaluating. Okay? We're not solving on both sides. So, here are some examples. I want to check if x equals 100. Well, I'm going to plug it into the equation. What is the square root of 100? What is it? 10. Does 10 equal 10? Yes. So this is a solution. Then if I go to number 2, I want to check x equals 1. What is the square root of 1? 1. Does that equal negative 1? No. Therefore, this is extraneous. Okay? We are so used to putting the plus or minus with this, but we're only looking at the positive roots. Okay? Now, number 3. X equals 25. Oh. What is the square root of 25? Does 5 equal negative 5? No, therefore this is extraneous as well. Okay? So you might get, and we're going to see, 2 possible solutions. Okay? You have to check them both into your original equation. Okay, so let's look at example 1. What do I have to do here? How do I solve that? What's your first instinct? Before that, we have to square both sides to get rid of that radical. So we have 21x plus 1. Then we have x plus 5 squared. Please do not tell me it's x squared plus 25 because that's incorrect. X plus 5 squared, how many do we have of them? 2. So what that looks like, okay. What do I have to do on the right-hand side? Go ahead. Okay. Is everyone okay? Okay. Now, since we have that x squared term, we have to set it equal to 0. So, I keep my x squared positive, so I'm just going to bring everything to the other side. So I have x squared minus 11x plus 24. Now what do you have to do to find solutions? Factor. So what multiplies to 24 and adds to negative 11? Good. Okay, so what are your 2 possible solutions? Eleanor? 8 and 3. Okay, that's great. We have 2 possible solutions. But now we have to check both in the original equation. So we're going to first start with 8. Okay, first start with 8. So everywhere I see an x, let's check this out. 21 is 8 plus 1. Okay, what is 21 times 8? 168 plus 1 is what? 9. What is the square root of 169? So I have 13 on both sides, therefore 8 is a solution. Okay, now I have to do the same thing with x equals 3. Okay, 21 times 3. Did 3 work? Yes. Okay, 21 times 3 gives you 63, plus 1 is 64. The square root of 64 is 8. You got 8 on the other side, so these are both solutions. Okay, so anytime your directions say check for extraneous solutions, that is what you're doing. Okay, finish up example 2 as our last one today. Okay, you're checking for extraneous solutions. Okay, for example 2, how many of you did get x equals 108? Okay, you square both sides to get 1/3 x minus 11 equals 25. Okay, then you add 11 to both sides. Then you multiply by 3 to both sides, and you get x equals 108. When you checked it, did it work? Yes. Okay, so you have 1/3 times 108 minus 11 to the 1/2 should equal 5. Well, what's 108 divided by 3? 36. Then you have 36 minus 11, which is 25. The 1/2 also means what? Square root. Square root of 25? 5 equals 5. Good. Okay? So that's what you want to always do to check for extraneous solutions. You definitely will need your calculator on Thursday. Okay? Your graphing calculator. We are getting into, just so you could see the preview, 14. These guys here on page 14. We get into trickier types of problems. Okay? So you definitely will need your graphing calculator on Thursday. Your homework is in the blue packet, the 5.3 practice on pages 7 and 8.